It's a system. There's a line. Is it straight? Of course it is. When I say line, that implies straight. System means I got two of them. And if someone said to you, where's the solution? You would say, the middle. Okay. I know what you mean, but two lines that, yeah. Where they, what's another word? Intersect. That's the solution. So we're just looking at what are the total possibilities for lines. That's one possibility. There's two others. If two lines are parallel, what's the definition of parallel? We know the slopes are the same, and that's just how we denote they're parallel, by the way. Either we say they're parallel or we put those funky little arrows in there. Do parallel lines ever cross? No. Think train tracks. That's hard. That's a tongue twister. Toy boat. Think train tracks. Do they ever come closer? No. Farther apart? No. That wouldn't be good because then the train would crash. So, do these ever cross? No. What's the solution? There isn't one. It's a trick question. There is no solution. So there's another possibility. That's possibility one. That's possibility two. But they cross. Either they have one solution, no solutions, or here's the weird one. There's a line. I'm going to draw another line. Okay? Oh, my projector cut out. Hang on. I'm going to turn my projector on. Hang on. Oh, that's good. No internet. Okay. So I have a red line, there's a blue line. How many solutions? Is there a solution? There's one. Is there another solution? Oh, look, there's one. Like this is a point, a coordinate point that's the same for both lines. If they cross and have different slopes, then there's only one point where they have the same coordinate for both lines, right? Here, like how many points can you name? There's an infinite amount of solutions. And you might say that's silly. That's the same line. But written as y equals mx plus b, that's one line. That's the blue line. And here is the red line. I'm just going to multiply everything by 2. That's the same line, you can argue, but I'm going to say no. That's one line. That's the other line. Okay? Now let's try again. Okay? Those are two separate lines. That's your three possibilities. So let's look at this, okay? We're not actually going to do this, but we need a little more practice when we get to these word problems, which I'll just spend like a day on, because we got a short year, putting this stuff into English. You paying attention? Yeah. No, you're not. How do I put that in an equation? I'm not asking you. I'm asking the class. I don't want any words. 28, 4 is equals, like 28 bucks is 4 burgers and 2 salads, right? You like X's and Y's, like I said before, feel free to use them. But what makes more sense? Burgers? B. You like X, you use X. Okay. Salads? S makes sense to me. 34 bucks is 6 burgers and a salad. What's the number for a salad? 1s. I don't need the 1, but same thing. Okay? Just a little practice doing that. I'm not going to spend time doing this thing. Number of solutions. I said it. Now it's in your book. There's 3 different possibilities here. There's 3 graphs. Okay? This is an equation for one line. What form is this in? Slope, y-intercept. Y equals mx plus b. Okay? So quickly, this isn't a grid. I'm going to quickly graph that. We should know how to do this. I start with this. There it is. There's 5. My slope is what? 1. I rise 1. I run 1 in the positive direction. That's what that guy looks like, approximately. Okay? I don't need no graph paper. I don't need to spend time doing all that. That's kind of like what it looks like. This one, I'll do with a blue line. Here, the y-intercept is 1, and my slope is negative x. So it's, again, rise 1, run 1 in the negative direction. So that's kind of generally what that looks like. Is there a solution here? I.e., do the lines cross? Yes, they do. Okay, there is a solution. So, if the lines intersect at one point, like these two did, then I have one solution. And you guys found solutions yesterday. Let's just try to, instead of just solving it every time graphically, what's the little shortcut? And everybody loves shortcuts. What do I know about the slopes of these lines? They're different. That's all you need to know. Okay? Because if any two lines have different slopes, are they going to cross eventually? I don't care what two lines, even if the slopes are really close together. If they're different, they're going to cross, and you're going to have one solution. That's it, because two lines can't cross more than once, right? Think about it. Different slopes, they cross. Different slopes, one's undefined, one's a slope of 0, but they still cross. There's still a solution. Okay? That's all you need to know. If the slopes of two lines are different, you have one solution. Let's look at this scenario. How do I graph these? This one I'll do in red. -8, start with the y-intercept, slope of 2. So that's going to be a little steeper than this one. I rise 2, I run 1 in the positive direction. Kind of looks like that. This guy, blue, now it's +6. And what do you notice about the slopes? They're the same. So you're going to try to write these, draw them, as parallel as you possibly can. Because you do know that the same slope means they're parallel, right? Do parallel lines ever cross? No. If the lines are parallel, how many solutions are you going to have? No solution. If they're parallel. Okay? So they already put this down here. If the slopes are equal, but we have to look at something else too. And they have different y-intercepts. Because what happens here, okay, if I have the same slope and the same y-intercept, that's this scenario. Well, let's have a look-see. I can graph this guy. Let's make it red. Start at -2. My slope is now 3. That's even steeper. 1, 2, 3, and 1. Okay? This, do we know how to graph that, son? No, you don't. Yet. Because that's in general form. You have no idea how to graph that. So I want to make this look like that. Okay, solve this thing for y. All I got to do is take that minus 2y, chuck it over here, and change the sign. And then what do I got left? 6x minus 4. Okay? How do I get rid of this 2? Divide it away. And 2 goes into 6 3 times. 2 goes into 4 2 times. What do we notice? It's the same thing, isn't it? So let's graph that one. Well, it's right on top of the red line. How many solutions does this have if it's the same line? Infinitely many. How do we tell without graphing it? Because you don't have time to do 60 questions of graphing. You would need to know just looking at these 2 lines if it has no solution, 1 solution, or infinitely many. It has infinitely many if they have the same slope and same y-intercept. Okay? So that's your 3 possibilities. That's it. Don't graph them. When I say don't graph them, I mean you should learn how to do it without graphing them. If it is your test, and you have no way of knowing because you forgot or you were here away for 2 weeks, okay, feel free to graph them to get the answer, but you don't have time to do them all that way. Okay, so you should know looking at these which situation we have. So a couple of examples. How do I know if these guys are parallel and have no solutions, if they cross and have 1 solution, or if they have infinitely many? Can you tell by looking at those 2 things? I can't either. I got to know about their slopes and their y-intercepts. This, I know, has a slope of -3/5 and a y-intercept of 0, so I got to rearrange this guy. Okay? So 5y is put 3x to the other side, change the sign, 15 stays there, and then get rid of the 5. So y is -3/5 x plus 3. So what do I know? Do they have the same slope? Yes. So either they're parallel or they're the same line. What does the y-intercept tell us? Same slope. I'm here. Different y-intercept, which means what? They're parallel, but they never cross. I never wrote that, by the way. 2 parallel lines, right? Lines are, oh, I better say this too, coincident. One's right on top of the other. Okay, so this has no solution because it says don't graph it. Analyze them. Look at B. This one's y equals mx plus b. I know what's going on there, but this guy I don't. So put x over there, put 8 over there, change the signs, divide by -4, y equals mx plus b. And what do we notice? The slopes are the same and the y-intercepts are the same, which means I have this situation. One line, it's the same line. I have infinitely many solutions. Okay? Neither of these ones are in y equals mx plus b form. So let's rearrange it. Put x over there, change the sign, divide by -6, y equals mx plus b. And then this one, y equals, that one's easier, mx plus b. And guess what? We did this situation, no solutions. We did this situation, infinitely many. Guess which one this was? All you need to look at is this. If they have different slopes, I don't care about the y-intercepts, right? If they have different slopes, they're going to cross. I have one solution. Okay? That's basically it, guys. Just analyzing and checking out how many different solutions we're going to have. So this question, I think I'll save it and come back to it. I'd rather you work on this stuff first than confuse you with more word problems, okay? So 1 to 5. Try to tackle 6a. I've been showing you how to put words into numbers. All they want's the equation there. Attempt to do 7, part of it. It just says explain how to do it. It doesn't say solve it per se. All right, so try to get equations from there. 8, definitely. That's like a government exam question because it's multiple choice. And if you're really keen and you want A, do 10.